All right, so yeah, yesterday's homework, especially the first two questions. The first one you should get 1. Number 2 I'll show you. What?
Yeah, you put them in the book. I got pi over 4. Yeah. If you stop making baseless claims on Bill, I will take you in the book.
I'll give you answers. Okay, so let me give you answers first, and then. All right, so first one, the answer is 1.
How did you get that?
It's on that side of the board, but that's okay. I'll show you in a second. I'll check it. I'll show you the answer in a second. Let me show you the answer first. So, second one is a 1 over 1 plus x times 1 over 2 root x minus 1 over 1 plus cosine square of x times sine of x. 3 is 2. 4 is 2 because you got to take an integration between 1 to 3, and then you got to divide it by 2. So you're gonna get 4 divided by 2. So it's just basically integration problem. If you want to find the average value, you just have to divide it with. Number 4 is 2. Number 5 is 4. Now this one's kind of hard. This one's probably the hardest questions here. Is knowing that x squared minus 4x plus 3 graph has 2 x-intercepts. One is at 1, one is at 3. And between 1 and 3, wait, I should. No, I should stream this. Oh, I'm. Huh?
Fabian's in the hallway doorway. Can I go open the door for him?
Yeah, of course. No, just go down the hallway and then wave at it and walk back. So I will break down to 3 intervals, but I will be even smarter. I will do between 0 to 1, I'll times by 2. Because their parabola are symmetric. Right? If you're lazy enough, then you will find a short way. It's between 0 to 1. I will do it in terms of x squared minus 4x. I will do it in terms of that. X squared, this part is going to be x squared minus 4x plus 3 to this part, but I will multiply by 2 because 0 to 1, I can multiply it up by 2, and then I'll do an integration of from 1 to 3 of negative x squared plus 4x minus 3. Does that make sense?
Yeah.
So that's just me being lazy, but you know, for math, a lot of time, like the best solution are the most elegant solutions. You don't want to take forever to do something. You want to think logically, say what's to figure out the fastest path. For some of you guys that go in math competition, you're gonna realize that a lot of time computation questions are not difficult, but in order for you to think about the fastest course, you had to think about, you know, how to do things faster, and you had to think about, like, logically, can you shorten the steps, right? But because there was no way to complete the 30 question 30 minutes, 1 hour, sorry. Question 6, I got some C's 106/3. For me, I actually expand the top, split up, and then plug in initial condition, find out about you see. 7, we kind of talk about this. Is if it's v of t is a velocity, then I can just integrate between 1 to 5. That's going to give me a displacement. Now realize I did say displacement, not total distance. There was a difference between total distance and displacement. Yes.
For 7 was it 25t or was it 29t?
2019. Number 8, this is an easy one. This one just the graphing. The first one I got 5. Second one I got 15.5 minus pi. I got -39/2. I got pi plus 4. I got 3/2 for the average value. William's like, it's too easy. Anytime we're graphing is too easy, that's great. So I think there's one person that's watching. Hopefully it's Dania. If it's Dania, happy birthday.
I'll watch
Put a comment if it's your birthday.
5. 6.5 minus pi. It'd be 6.5 minus pi or 5.5 minus pi. I can't tell from this.
I think it's 6.5 minus pi.
Good, because that's what I got. 9. You got. I got 9.5.
Huh? See? I got -39/2.
-39/2.
Because I have to do integration from 4 to 1 of 2x. And I have to do that separately. Alright, so I'm gonna go ahead to talk about capstone question. I personally like the capstone question, has a little bit mixture of graphing understanding, an additive interval question. The A is -1.5, B is 5, C is 6.5, D is 3, E is 15.5, F is 7/12. William's like, this is too easy.
8 doesn't have an F. There's no F on the paper.
What's that?
A, B, C, D, E. There's no F.
We're talking about question 66.
Oh, 66. Yeah, I figured I answered them all except for F. That's just me not doing it. It's just me not doing it. 6.5.
Andrew Lopez is not here, but it's not his birthday.
No, I got that wrong.
He left. That's probably Andrew. Andrew's like wake up for a few moments and then probably go back. I'm going back to sleep. Can I go over number 2? Yeah. So you don't know how to take this integral yet. It's gonna be g of t is equal to 1/1 plus t squared. So that's gonna be integration of x and cosine of x of g of t dt. But you know at the end I want to find the derivative, so that's gonna be d to the dx afterwards. So up here, if I take integral of this, it's gonna be g of cosine of x minus g of g square of x minus g of cosine of x. Now, if I take a derivative after that, that's going to be g of square root of x times 1/2 root x plus g of cosine of x times sine of x negative. So then I'll just plug in the square root of x into the assumption. So g of t is equal to 1/1 plus t squared. So if I plug in the square root of x into here, I'm going to get 1/1 plus x. and then times 1 over 2 root x, and then times cosine of x into the 1 plus 1 plus 1 over 1 plus t squared. So that's going to be 1 plus cosine square of x times sine of x. And this is the only one that we learned new yesterday, besides adding value. I'm so sleepy. All right. So that I went over all the homework. So I want to talk about those of you guys did not complete. I'm not very picky today because I know a lot of you guys going through long night yesterday on the prison concert, but not everybody, but a lot of you guys. Ethan, right?
Hey, what did you put for E?
But I will go back and make sure I know how to do all the homework questions.
15, right? I don't know how I got 9. 15.5. I don't know how I got 9.5.
15.5. Yeah.
Yeah, because the 2 times the distance of 6. Because you put the 2 on the outside, you multiply times the distance.
You have to add 9.
And then,
Because the integration from 9 to 2 to 1 to 3 is 9. 9 plus
right, we're doing 66E, right?
66e.
Yeah,
I don't know. I didn't do it.
right there. 15.5.
Oh, you had to add 12 because between
Yeah, you
0
need to add 12
6.
because it's the 2 times the 6.
Yeah, and then that's 3.5.
And that's equal to 3.5.
So it's 15.
I don't know how. I think I made some sort of 15 minus something. I don't know. I can't read my handwriting.
All right, so this video it's gonna be 25% your grade, so it's gonna be approximation. It's gonna be a lot easier. So if I were you, I will really pay attention. So start with the approximation. Everybody need to understand how to do approximation, but why we're doing approximation first. So first of all, I'm giving you overall spec of everything. So like a big picture of what happened. Okay, so in order to find area under the curve, we talk about is integration. However, at first, that you can really know how to find area integration is start with the approximation. I think when you're younger, they usually give you like some a picture of an island like this, and they say what is area of the shape, and you just pretty much count the squares. Do you remember that? You go inside, count 1, 2, 3, 4, 5, 6, 7, 8, and there's like a half of a square, and this is like 1/3 of a square, and you're trying to add up as accurate as you can, and you got this area of this weird shape. Like they say this island, and if this island's on a grid, and you want to find out how many square mile that is, and basically you do this. So same thing about integration. Integration start by approximation by looking at the area under that curve. Now, there are a few different type of approximation. Okay, first, there is a right either use the right end Riemann sum or right Riemann sum. So I'm gonna say right Riemann sum. Now Riemann is not a word; it's a person.
How's that spelled?
I think it's spelled as Riemann, but don't quote me on that because I have no idea how to spell anything in life.
Riemann.
I'll tell you in a second though. MANN. Yeah. So Riemann sum, Riemann is like a very famous mathematician. He does like some crazy stuff. I don't understand half the thing he does. But he have a lot of contribution to area under the curve. But start with a Riemann sum, which is area under the curve. It's right and left though. Okay, so 2, there was a left Riemann sum. Third, somebody else says, hey, I can be more precise on doing things. Probably better approximation is going to be trapezoid. But we don't call it trapezoid rule. We're just going to call it trapezoid rule. Basically, just add up each trapezoid. The fourth one, we're going to call the midpoint rule. Okay, so there are 4 different type of approximation. Left end, or we call it right end approximation or left end approximation. Sometimes they including the end here. So depends, right? Depends on what is it. Now, also in mind is there is a between the trapezoid rule, there are calculus like to give you 4 different way to ask you to interpret. So one is A is going to be function, so they usually give you in terms of function. B usually in terms of graph. C, the most popular in this particular question, is going to be the table. And I think table, usually they give you irregular. So with this, there is you can choose to have 2 type. Is 2 type of situation. I will say there's regular intervals and irregular interval. I know right now it's really confusing, but I'm trying to show you the big picture. I'm gonna give it to you in a second, and it will make sense in really quickly. Now I'm gonna talk about 4th grade. When I was 4th grade, I learned this thing, and I thought like teacher is kind of like stupid. Why is he teaching this? And not until I go to calculus, I realize how important this is. So in 4th grade, I learned that if there's a 5 tree in a row, let's say 1, 2, 3, 4, 5. If there's 5 trees in a row, how many space between trees?
4.
It's a 4. Right? So there's 1, 2, 3, 4, but there's 5 trees. You thought that's 5 spaces, but it's actually 4 spaces because the first one and second one form the first space. So also another way to figure out the equation of this is n minus 1. Why? The amount of tree minus 1. Yep.
Every one of them needs only 1 more, except for the first one, which needs 2 more.
Okay, yes. So there are 4 spaces here, but there's 5 trees. Very important. It's gonna come back to click. So I'm gonna show you the big picture. Now, another big picture I would like to show through decimals. But I will show you later. So first of all, I'm gonna give you 4 equal intervals. So situation is gonna be like this time. I'm gonna give you intervals. I'm gonna give you x and y, and I'm gonna start with 3, and each interval is the same. Do you see that each interval is the same? 3, 6, 9, 12, 15. And I'm going to give you some numbers. So probably like 8. The second one probably 6. Third one's probably 10. The fourth one's probably like 16. And 4, something like this. So we have x and y value. So we're going to say this is the f of x is equal to y. Now for me, the trick is this. trick is actually drawing. So right now I'm not gonna be very precise, and the way I draw, I think this is the easiest way to do something, but I don't know. So I'm gonna go to like each space is 53. Is that okay? So this is 3, 6, 9, 12, and 15. Is that okay? So I'm gonna approximate a value. So the first one is 8. So roughly this 2 space is 8. I'm gonna write down 8 right next to it. Somebody trying to hijack my live stream? A bit. How can you let this happen?
I have negative technology aura. Everything.
I was making my mathematical aura.
Everything near me breaks.
Counters a bit and yeah. So the first space I label 8 on the first point. I label 8 there for a reason because I can tell that the height is 8.
Yeah, I can't graph.
And I'm gonna label the second one that's a little bit less. I'm gonna label it 6. And next one I'm gonna label a little bit more, it's 10. And next one is gonna be 16. And the last one is gonna be 4. Like this. So I label each point because that tells me the height of each point. So I'm gonna copy this. Okay. So first of all, I'm gonna show you right hand approximation. So right, oh no, sorry, left. Sorry, I want to start with left. Left and Riemann sum. The biggest thing about width of regular intervals, width of regular interval is equal to b minus a over n. So the distance between 15 and 3, so I'm gonna get 12, right? I'm gonna divide it by what those total amount, 4 spaces. I'm gonna divide by 4. 4 equal spaces. So the first part, I'm gonna use left and Riemann sum. And the way to draw it is gonna draw particularly look like this. You see, I use the left end to use my first point. Do you realize that? Now, I did not use 4 because I only have 4 spaces. So I didn't use the last value because the 4 spaces. Does that make sense? Does that make sense? I told you a story why there's 4 tree, the 5 tree, there's only 4 spaces. There was one spaces, one number I did not use. So this will give me an approximation. The easiest way to write approximation is to figure out the width. What's the width? Each width of a rectangle.
3.
Great, but it's also getting by b minus a over n, right? So that's going to be 15 minus 3 over 4 spaces. So that's going to be 12 over 4. That's equal to 3. So I can do like this, 3. And I can just multiply by height of each rectangle. So it's going to be 8 plus 6 plus 10 plus 16. Do I need to add 4?
No, you never have a height before.
Yep, I don't because I use left hand approximation. Yes.
How do you determine n?
Left. They will tell you. They will say left or right.
Well, how did you get 4?
Because there's 4 spaces.
Yeah. There is a 4 spaces here. Oh, so this is 1, 2, 3, 4. So 4 spaces. So that's 4 equal interval. Is that okay? No. Now I'm gonna say, hey, can you use the same method but figure out the right Riemann sum? Yep. So it's also right Riemann sum or right endpoint Riemann sum. I'm just gonna write it fully because sometimes they do right end right end point. You quickly recognize I don't use the leftmost point. I only use right foremost point. Does that make sense? So the width is still the same thing. It's 3. Now it's going to be 3 times f of 3. No, not f of 3. F of 15 plus f of 12 plus f of 9 plus f of 6. And that's equal to 3 times 4 plus 16 plus 10 plus 6. And that's equal to whatever. I don't know what that value is, and I don't really care. But you guys have fast at calculation, 24. This is 120, I think. And the second one is 36, 108. And what mathematician says, well, you know what, be more precise if we can average both. Because one of them is 120, one's 108. It's going to be average of both. So it'd be, but the way I draw a rectangle is going to be this though. So this rectangle is based on 4. Do you see that? Based on 16, based on 10, based on 6. And do you see that this is a little bit under approximation compared to the last one? Well, right side, and we're going to talk about it over under in a second, but is this okay? Now, I'm going to show you the big picture. Big picture is with the idea of limits. And with the idea like I can break the rectangle to as many pieces as I want. I can assume that n can approach infinity. Then that's the idea of area of the under the curve. But I'll show you what a big picture look like in a second. So there's a big picture of what it look like. If I go to the bottom, and this is very, very, very nice because this is Riemann sum right here. And we have this function. It's like a very curvy. We want to approximate 1 to 4. And we want to show you what it look like. And a left hand approximation is going to look like this. And that's only 16 intervals. Got it? Now let's look at, they'll actually give me a value here. It's about 4.977. A little bit, sometimes over, sometimes underneath. And I'm going to use the right endpoint approximation. Let me see what's this. Is 5.54, right? Now, if I take a 5.54 and 4.97, if I average them, what am I going to get? Roughly 5.25. But you see on the bottom here, they also say actual value between integral between two values is going to be 5.25. So the idea is use the right Riemann sum and use the left Riemann sum and you average them. Hopefully you get some value right in between. It can be very precise. Now, that's only if I break the 16 rectangle. Imagine if I break this to 1,000, right? 871 to be exact. I'm going to break it to 871 pieces. I'm going to see how accurate they are. Well, still a little bit off, right? If you zoom in enough. But if you break the infinite amount of pieces, what am I going to get? But look at the area though. 5.25 for left, for right, and 5.24 for right. It's only like 3 decimal points away. How accurate it is. And that's 871. Imagine you can break the infinite amount of pieces, and that's what the actual area under the curve come in. We're not going to talk about a formulation of the definition of integrals, but that's the idea, because I don't want to spend a week and you guys get nothing. I'd rather understand the basic approximation. On your test, you just have to do this. You just have to do this. You just have to do this, and you just have to do this. And sometimes you don't even need to show the answers. On AP exam, if you write out everything, you don't even have to show the calculation because they know you know how to plug in the calculator. Am I going too fast for left and right? Okay. Now let's talk about a little bit harder. Trapezoid. So what is trapezoid rule? Now, and instead of, don't want to waste a lot of time. I don't want to do 4 equal interval. I'm going to do 2 equal interval. Two equal intervals. Now remember, your homework might get irregular interval. Irregular interval is just going to add each trapezoid because their height is different. Some value is 2, 5, 4, 2, 5, 6, 8. Then each rectangle is going to be different width. Then you're going to add it according each width on your homework. On your AP exam as well, sometimes you're going to be like that. Sometimes you have to plug in a value to get the functions. But let's just do 2 trapezoid rule. 2 trapezoid rule, what would it look like? Can you tell me what's each width of this trapezoid, or the height to be exact? What's each height of this trapezoid? What? No. 6 is correct. Because you're going to break it up to 2 spaces, right? So this is 6, right? Now I'm going to draw a trapezoid. So the trapezoid is going to be like something like this. They're different height. The trapezoid, this one's a little bit less. So look at this, it's like a under approximation. So a trapezoid of this one is going to be, or the height of a trapezoid is 6 times a plus 10 divided by 2 plus 6 times 10 plus 4 divided by 2, because that's an average basis. And if you write this out, I think you can get a good credit. So does that make sense? This one is the first trapezoid, and this one is the second trapezoid.
So what always left a value?
What?
What always left a value like 16?
What?
We're not gonna use the 15.
No, because we use 2 equal interval. If I use 4 equal interval, then I would use 16. If I would use 4 equal, that would be even better precise, right? So let's just say if I have 4, I'll draw it for you. 4 equal interval versus 2 intervals. One is going to be like this, so I'm going to use this one. If it's 4, it's going to look like this. It's a better approximation, but it's more work. But I'll do it just for you. So it'll be 3 is the height of each one. And it'll be a plus 6 divided by 2 plus 3 times 6 plus 10 divided by 2 plus 3 times 10 plus 16 divided by 2 plus 3 times 16 plus 4 divided by 2. Do you get a point? Now, remember, on your homework, you might get irregular. So it could be like 3, 5, 9. Then the first interval is going to be 2, right? Because your interval might not be the same. Your homework, you have to pay attention on the intervals, because interval might not be the same. Okay? Where is it? Class N? No?
Six.
I have what?
15 minutes.
I have a lot of time. Okay, so trapezoid rule. Did everybody understand trapezoid rule? Next thing. Midpoint. Midpoint can only do 2 equal intervals. Why? You cannot do it 4. Midpoint, you cannot do it 4. Because if you have midpoints, midpoint rule, then it has to be 2 equal intervals.
What happens if it's an irregular?
And you cannot do midpoint. So midpoint doesn't work with the irregular. Not working. Not work. So this, it doesn't work with the irregular. Only an equal interval. So if you see equal interval, a lot of time they will ask you midpoints because that's the only way you can use the midpoints. What do I mean by that? Imagine I have post here. So I have few points and I only can use the midpoint. So that means I cannot use, there's only 3, 9, and 15, right? If I do 2 intervals. But the problem is I cannot use any of those values. I have to use the middle of those 2 values. So then I'm drawing this. I'm drawing this in middle of the value. I don't use this n. I don't use this n. I use the middle. So what I'm saying is, that just say if I break this 2 intervals like this, right? And usually you would use 3, 9, and 15 as a right end or left end. But the problem is I don't want to use left or right. I want to use the middle of left and right. So therefore my first trapezoid, the first rectangle is going to be based on this. And second one's based on this. And all you got to do is the first one's 6 times 6. Plus the second one is going to be 16 times 6. So it'll be 36 plus 84. So it'll be 120. So 120. It's pretty good approximation compared to it's almost same approximation left endpoints. But every time it's going to be slightly different.
It's supposed to be 96, not 84.
96. I'm sorry. Can add. Chat. Sorry.
136. If you go to 136, 124,
132.
132. No, I cannot.
That's okay. I cannot multiply.
Hey, I can't spell.
I can't do any of them.
Perfect.
I'm illiterate. Okay, so we do 4 different approximations. Now let's try a couple with irregular. Irregulars are going to be slightly different. So let's just say if today I have x and f of x, and let's just say if I have 2, 5, 7, and 11, something like that. So that says I'm just gonna 10, 2, 4, 8, and 15, something like that. So what if I use the left end here? So let's just say if I use the left end, how many spaces are between them?
3.
So you should get 3 rectangle, right? So left end is going to be using this. 10, 4, and 8, right? So the first rectangle is going to be 3. Space is 3 times 10. Does that make sense? Is that okay? The second one, the second space is what? 2, not 3 anymore. So pay attention to the interval. So this is 2 times 4. What's the third space? 4, so it'll be 4 times 8. And there we go, you're done. You just did left-hand approximation. So this one, you don't have to know calculus. You just need to know how to add and multiply.
That's
Which is, I know Kushan's not very good at.
a little harder than
Because I was only use left. If I would use right, then I would do 15 times 4, 8 times 2, and 4 times 3. Does that make sense? I can also do trapezoid. Trapezoid has different width. You cannot do midpoint. Thank you, Emmy. See, Emmy, today you pay attention. That's good.
Only today?
Yes. Huh?
Oh, I said.
Can I give you in terms of functions? Okay, so let me try this. F of x equal to 4 to the x. 4 to the x. Okay? And from 0 to 2, I want a 4 intervals, 4 equal interval. 4 equal interval. And the right hand approximation. Four to the x, 0 to 2. This time you had to build your own table. 4 intervals. So the hard part is only build your own intervals. That's it. No. Yeah.
Intervals total?
There's 4 total intervals. 4 total spaces.
So I need 5 numbers.
Well, the first number is easy. It's 0. But if you use right, then you can you can get away with 4 number. Just use the 4 most right. But the table you should do everything, right? So what is the first? 0, right? Half. 1. And what? 3 over 2.